Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 245. Please turn to it. Page number 245, and today is our lesson number 358. These problems that you see there on page number 245 are the exact same problems that appeared in the first edition of the revised GRE. We have already solved every single problem from this book. If you're interested in watching the original solution to the problem, you will find it on day number 151. Please turn to it. Number 17. Problem number 17 is what we are about to do. Problem number 17, if you have the book in front of you, you will see that it has a picture that goes with it. So let me reproduce the picture here. We are given a triangle. Looks something like this. And we are told this is P, which is -2 and 6. We are told this is Q, and this is R, which has the coordinate of 5, 0. And we also told that it makes a right angle, which is very important. This is the most crucial part. This symbol is the most crucial part in the problem. Otherwise, we cannot answer the questions that are being asked. It is a right angle triangle, which means the line PQ is parallel to y-axis. Line PQ is parallel to y-axis. Let's get going. The very first question they are asking in number 17 are the coordinates. Is the coordinates of point Q. Number 17, coordinates of point Q. Well, point Q is right here. Point Q is right here, and we just discussed this line PQ is parallel to y-axis, which means the x-coordinate of point Q is going to be the same as the x-coordinate of P, which is -2. So it's going to be -2, and of course the y-coordinate is 0 because it's sitting right on the x-axis. -2 and 0. So that was straightforward. Part B, they're asking us for the length of the three sides, PQ, QR, and PR. Let's find out. The length of PQ is very straightforward. From Q to P is the vertical distance right here, which is the y-coordinate of point P, which is 6. Y-coordinate of point P, which is 6. Q to R is also straightforward. Q to the y-axis is going to be 2. This distance is 2, and this distance from here to here we know is 5. So it's 2 plus 5. It's 2 plus 5. And finally, the distance P to R, let's call that X. P to R, which we are calling X. We can find that out very easily by a simple application of Pythagorean theorem. We have a right angle triangle here, and we know this is 6, we know this is 7, and this is what we're looking for. Very straightforward. So x squared is going to be 6 squared plus 7 squared, which is 36 plus 49. 9 plus 6 is 15, 5, carry 1, and then 85. So x is root of 85. Root of 85. That takes care of part B. What are we asking in part C? In part C, they're looking for the perimeter of PQR. Well, the perimeter is going to be the sum of the three sides we just found. It's going to be 6 plus 7 plus root 85. Let's do it on the top here. Perimeter is just going to be 6 plus 7 plus root of 85. Let's move on then. We're done with this part. Let's move on. Now listen, I'm going to make a little digression here. If you had to, listen very carefully, this is nothing to do with the question. They're not asking for it. As far as the problem is concerned, we are done. It is 13 plus root 85. That's it. We are done. Now let me ask you this thing. If you had to estimate during the course of the solution of a given problem, if for some reason you got to a place where you needed to estimate the root of 85, are you able to estimate it very quickly without having to resort to the calculator? Can you do that? Let's talk about it for a second. Okay? This is only for learning purposes, nothing else. It's nothing to do with problem with us there. But we know that 81, root of 81 is 9. 85 is very close to 81. Let's try 9.1, shall we? Let's see what happens. 9.1. Let's try it here. 9.1. 91 times 91. Let's just see what happens. 1 times 1 is 1, and then 9. 9 times 1 is 9, and 9 nines are 81. And we get 1, 18, 2. Now what does that tell us? That tells us that 9.1 times 9.1 is 82.81. 82.81 in my opinion is very far from 85. We need 85. We got to get this closer to 85. Let's try 99.2, shall we? 9.2. So again, when you have to do 9.2, you don't actually have to multiply 9.2 by 9.2. That's bloody annoying. Just do 92 times 92. 2 times 2 is 4, and then 18, and then 9 2s are 18, carry 1. 81 plus 1 is 82. And we get 4. 16, carry 1, we get 4. Ah, there we go. Which tells us that the square root of 84.64 is equal to 9.2. You see, it's 9.2. Which means we can say that the square root of 85 is approximately 9.2. So if you had to estimate very quickly, this is how we would do it. And of course, in the real exam, I wouldn't have tried 9.1. You could tell you should have these kind of gut feelings and this kind of intuition you develop as you practice more with the numbers. You should be able to tell that 9.1 is probably going to be a bit too small. 9.2 was the very first thing I would have liked to try myself, and it works out fine. 9.2, square root of 85 is approximately 9.2, because square root of 84.64 is exactly 9.2. So this whole thing is 13 plus 9.2. Now, technically this is not right, because square root of 85 is approximately 9.2, so this is not correct here. So now we have to replace it with approximately. That's it. And 13 plus 9 is 22, so it's 22.2. The perimeter of this thing is approximately 22.2. That's all. Let's go on. Part D. In part D, they're looking for the area of the triangle PQR. Well, the area is going to be 1/2 base times height. For base we know is 2 plus 5, which is 7, and the height we know is 6 right here, the 6 part. So if we divide top and bottom by 2, the 2 cancels out and this becomes 3, and we get 7 times 3, which is 21. The area of this triangle is 21. Let's move on there. Anything else? Part E. Oh, part E, they're asking several things in part E, 3 things actually. Let's look at part E. We need the room obviously, so we need to erase everything. In part E, they're looking for, first of all, the slope, the y-intercept, and finally the equation of the line PR, this line right here. What's going to be the slope of this line? Well, slope is very straightforward. Slope is just change in y over the change in x, which is simply y2 minus y1 over x2 minus x1. Now it doesn't matter which one we call which one we treat that as a final point and which one we treat as the initial point. It makes no difference. Let's just call this thing x1 and y1, or we could have done the other way around. As I said, it makes no difference. And this is our x2 and y2. The point here is that you have to be consistent. So this is our x2 and y2. So y2 minus y1, y2 is which is 6, y1 is 0, so it's 6 minus 0 over negative 2 minus a positive 5. 6 minus 0 is just 6 over negative 2 and minus a 5 is going to give us negative 7. So the slope is negative 6, 7. The slope of the line is negative 6, 7. Let's make a note here. Slope is negative 6, 7. So that was part 1. Now in part 2, they're looking for the y-intercept, the point where it cuts the y-axis, which will be easier to figure out if we actually have the equation of the line first. So let's do the equation first, shall we? And we're going to make use of the slope here because we know the slope is negative 6 over 7. The equation of the line, to find the equation we're going to use what is known as the point slope formula. This is not the only way, obviously. There are several different ways we can figure out the equation of this line. We could have used the format of 2 points because we know the coordinates of 2 points, or we can do one of the points and the slope, which is what we're going to do right now because we know the slope. Now, the point slope formula is so called because in order for us to be able to use the point slope formula, we have to know the coordinates of at least one of the points the line goes through. We actually know the coordinates of 2 of the points, and we have to know the slope of the line. Now, because we know the coordinates of the 2 of the points, we have to make a decision which point do we want to use. Listen very carefully. So this is how the point slope formula goes. Y minus y1 equals m times x minus x1, where m is the slope. The question is, which point should we utilize here? We could use either this point or that point. So listen very carefully. When you are in a situation like this, where you have two points or 3 points, and you have to make a decision as to which point to use in this format, take a couple of seconds and take a very quick look at the 2 points. If it turns out that the coordinates of one of the points involves some sort of a fraction, for example, if this was 3/7, if this one has a coordinate of 3/7 and some other thing, if I have a choice between using a point which has a fraction in it, whose coordinates involve fraction, and other points whose coordinates are whole numbers, then obviously I want to use the one with the whole numbers. You will end up doing less work. Similarly, take a quick look here and see if one of the 2 points has actually 0 in it, either x coordinate or y coordinate is 0, because if it's 0, 0 means less work. 0 times anything is 0. Right there is a 0, we're going to use that. And also it just turns out that that's our x1 and y1. So let's do it here. Y minus y1, you see y1 is 0, we won't have to do any work, this makes it easier, equals the slope, which is negative 6/7, x minus x1, which is negative 2. Is that correct? No, x1 right here, which is 5. That's it. So this is just y. Y equals negative 6/7 x, and then plus a negative 6/7 times the negative 5. You see, negative 6/7 times the negative 5 and negative 6/7 times x. Negative 6/7 times the negative 5 is going to give us positive. It's going to give us positive 30 over 7. There is our equation. There is the equation of the line. And finally, they are looking for y-intercept. Y-intercept is the point where the line cuts the y-axis, which is right here. The point where the line cuts the y-axis, the x-coordinate of that point is 0. Which means if you plug in 0 in this equation, we're going to get 30 over 7. The y-intercept is going to be simply negative 6/7 times 0 plus 30 over 7. So it's just 30 over 7. We didn't actually have to do all of this thing. Just by visual inspection, if the equation is written in the standard form, this is the standard form, which is y equals mx plus b. This b is your 30 over 7. The slope is negative 6/7. If the equation is written in the standard form, then just by visual inspection you can tell that this is the y-intercept. Right there. That's it, we're done. The y-intercept is 30 over 7. I'll see you tomorrow, okay? Bye now.